FlyNOW Aviation, presented by Yvonne Winter. Floor is yours.
Thank you so much for having me to this introduction. I hope I'm good audible, because sometimes there is a bit connection issue. Hopefully this is not appearing this time. It is a great pleasure to be with so many like-minded people and experts in the field of AAM, and especially this fills me with joy that you're all coming together and you're not fighting each other. This is how we make this work in collaboration. And maybe I start with a small thing. What I recently watched a movie, and it is a Netflix movie about the song "We Are the World, We Are the People." And the interesting thing is that this song was created in only one night by the best artists at that time, who are usually big egos. And to make it in such a short time, in such a perfect orchestration, it's really outstanding. And the organizer wrote a big sign and put it in the entrance and wrote, "Let your ego out." And I think this is necessary because we all serve the countries we are working in and for. We serve the people, the citizens, and we are on the edge to make something outstanding possible. And why is AAM so important? Because we are getting on a limit for our infrastructure. And if you allow me, I would share a presentation. Hold on, I hope it's working. Can you see it? Fully? I put it in presentation mode. So what we did is we developed a modular family of e-copter, electric helicopter flying automatically in predefined route that serves different use cases. And I mean, this is the reason why we do it. We all want to escape the traffic, and we want to bring a means of transportation that is really solving the issues on one hand, is sustainable on the other hand. And in order to be able to implement a new means of transportation, it has to be safer, it has to be more convenient, it has to be made in the same price, it has to fulfill everything that makes it worth to substitute it, or to substitute other transportation means. So what I find really interesting as a start with is to dig into what are the average infrastructure costs per person kilometer. And it's very interesting. We all say, yes, trains are the most sustainable ones and whatever. But when we look at the cost factor and on the infrastructure side, then we discover that the train system is the most expensive from an infrastructure point of view, and the aircraft are the less expensive ones. And having this in mind, it's the question now, how do we develop a system that is applicable for a broad public in order to really create impact? And our intention here is to be the Ford Model T of the sky, in order to come up with an affordable, safe, urban air mobility solution for the broad public and for many other use cases. We dig into the challenges that we face by implementing urban air mobility. And first of all, it is the noise issue. And from a noise point of view, I can tell that our aircraft emits only 55 dBA in an altitude of 150, which was the sound level of a dishwasher. In terms of safety, this is the most critical factor here. We have a 4 times redundant bed times redundant multi-redundant the software and flight control computer can auto-rotate. And of course, within the operation, there's a multi-redundant system as well. What we feel is very important is the price point. So we have a 10 times lower production cost to almost everyone in the industry. And the reason for that is that we are working on automotive production methods. So we use automotive production methods in order to really scale. And we have a modular system, so we share the same components for the different derivatives. So the same rotor blades, e-motor, harnessing, landing gear, battery for all the different derivatives. And in terms of regulation, we are blessed to have a bit of head start as we are considered being a helicopter, as we have only 2 rotor blades. And therefore, our certification is through CSVLR for very light, and CS27 for helicopter. And we don't need to wait for CSVLR to be issued. Which makes us, which gives us a real advantage. Then the energy efficiency, I can proudly say that our configuration is the most efficient system that's ever been built. The best proof point maybe for this is the Mars helicopter developed by NASA that was sent to Mars to detect the surface there, called Ingenuity, and it shares the same configuration like a coaxial rotor system with a tilting head mechanism. In order to be able to unlock the potential of 3D mobility on a broad scale, it is important to have a different air traffic management system. An air traffic management system that allows the broad, safe, scalable, and highly automated implementation of altitude by having the safety standards of an air traffic control or air traffic management system, and as well the possibility for a broad implementation like we only see in the teams. From an quite aware that we are an OEM, but there is an entire ecosystem that is required from, as mentioned, the traffic management, the physical infrastructure, weather data, digital tooling, connectivity. And when I went to an authority 2 years ago here in the kingdom, they said, well, this is a wonderful product and we need it, but how do you envision to implement? And I said, well, we do have partner companies for all the ecosystem that I just explained. And he looked at me and said, okay, but we need to work with 8 different entities here, right? And this was the starting point when I went back and talked to my colleague or colleagues, and we founded this International Sky Alliance for Automated Air Mobility, where we partnered up with all the necessary stakeholders from the ecosystem. It's an open system for different audience, for different solutions, because we believe in collaboration and not a competition, because we think the market is huge, it's not huge, and therefore we need to stick together in order to make it happen. And the last point is, of course, the public acceptance, and the public acceptance is achieved if it is available for everyone and not only for the super rich, and on the other hand, that creates solutions that serves them in many issues, being in rescue, in firefighting, in medical supply. So here you have a brief overview of our series of e-copter. On the right-hand side, the cargo version that can transport 200 kilograms in the size of a Euro pallet. Then a single and a twin seater. We always get the question, oh, don't you have a 4-seater, a 5-seater? And our answer to this is clearly not, because first of all, there is a sweet spot between the weight and the battery capacity and the range. And on the other hand, we are talking about individual mobility. So we try to substitute ground-based transportation like the Uber and Skype. And when you order Uber or taxi, that for yourself or for your partner, and you don't want to wait till 3, 4, 5 other guests. We have as well a firefighting and medevac. I come to this later. The range of the aircraft for the pure battery version is 50 kilometers. The hybrid version can go up to 200 kilometers, and we have a speed of 130 kilometers per hour. And for all the derivatives, it's a payload of 200 kilometers. What are the different use cases? Of course, on a long perspective, starting with 2029, we focus on air taxi, on tourism applications, etc. But we start with cargo applications. First of all, because of our certificate, which I come into in a minute. And on the other hand, because we believe that this is the much safer. So our approach is to start this year with a sandbox together with all the relevant stakeholders to really develop and try the operational topics. So to really see in terms of collision avoidance, bandwidth, connectivity, vertiport, and everything that you have discussed already yesterday. And then start with cargo applications over low and non-populated areas, like integrating it into logistic chains, fly into remote areas, doing port-to-shore operation, and so forth. And then second step, the personal variant and the medical evacuation, rescue, firefighting, and other use cases. In terms of the certification roadmap, since end of 2020, already we got the first approval in the specific category SAIL 2. So we are now testing the second iteration of the one-to-one prototype. We had to fly a long time tether as we tested on Salzburg Airport, very close to the main road and very close to the private jets. So we had 50 meters from this point, and therefore we need to fly tethered. Now we have the opportunity on a different airport where we can fly untethered and fly around, which is a big relief for us, and is really a lot. And yeah, so the next step, and we already got the okay from the air authorities to move now to SAIL level 4 and start with SAIL level 4. SAIL level 4 means in the specific category that we can already do commercial cargo transportation. And after we gained a lot of experience in this category, we then move on to the certified category, which allows us then to transport people on populated. For us, sustainability is a major point, and sustainability has different angles, and we want to tackle all 3 columns of sustainability, and this is economically, ecologically, and social. And when we look, for instance, on the weight of our aircraft, it is around 350 kilograms. If you compare it to a battery electric car that weighs average 2 tons, and the occupation of a car is usually 1.3 passenger all over Europe. So it makes sense to come up with a single and a twin-seater. And if you compare that, you can save a lot of resources, a lot of energy in the production as well as in the operation, and you can save a lot of resources in terms of infrastructure. And when we look at the pressure that is on the infrastructure, especially India, so I have been visited to Delhi and as well end of last year to Delhi. And when I look at the traffic, there has to be a relief and a solution. Yeah, so here I would stop my presentation and I would give some chances to ask questions. Otherwise, let me know I continue, but yeah, let me know. So everyone is on mute. I assume there are no questions. Let me know what topics you would like to dig deeper into. Potential I share about of our technology. So it's coaxial rotor system. It's counter-rotating, and by increasing RPM, it can and time, and by tilting the entire mechanism in the direction you're flying with of freedom. The other advantage is that as the RPM is not so high as we have large rotor blades, the noise is less, the downpour is comparatively less to other aircraft. And if you look at all the different configurations that are out there, it's a very simple and easy to maintain concept. So what we really focus on is a simple concept that is easy to maintain, easy to set up, and easy to transport. So everything is thought through till we deliver it to the customer and as well the usage. So for instance, eight of the helicopters in a 40-foot container or 4 of them in a 20-foot container. Here, what is the flight endurance of the helicopter? Good question. It's 50-kilometer range plus 25 kilometer for safety reasons. It equals approximately half an hour flight time. So is there anywhere where the questions appear? Because I just saw them popping up. One help me with this? All right. So if not, I'll just continue. I think what is as well unique is the less footprint. So we can land on almost every rooftop, everywhere as well. This is very good for disaster relief. So on a 10 by 10 meter field, we can store 14 of our helicopter, which is especially for logistic operations or for air taxi operations within a city, a very important prerequisite to do. And yeah, as well, what is important, we don't have any pilot. We are flying automatically, not autonomous. Automatically means like known in the aviation with an autopilot. Autonomous would mean that the helicopter or the vehicle itself can decide every millisecond where to go and what to do. No air authority wants that for a good reason. And I recently got the question, and it was very interesting as well. Why don't we use a swarm technology that like they use in China for routing the? So the answer is very simple, because this is an orchestrated system. It is under UTM, which does not fulfill requirements in terms of safety for transport passengers on one hand. On the other hand, still accidents appear. And in case there is rerouting necessary, in case there's any interference, or for instance, emergency helicopter, then the whole system is not going to work. And therefore, this is not a system that would work and that we could apply. So I think the biggest challenge that we have to face in this industry is to come up with a new air traffic management system that allows broad implementation in a very safe manner. And how do we achieve that? It's more or less a paradigm shift from UTM and ATC, because one air traffic controller currently can only handle 10 planes simultaneously. So when we have the operation of thousands of vehicles in a confined airspace, then this is of course not possible. Then there are some ideas of dividing the airspace into so-called U spaces, U spaces. This as well as a challenge, because when you imagine you have a big city and from a mall you want to start a small run with a medicine, you want to start cargo helicopter delivering a wash machine, and you want to have a large eVTOL with a pilot landing and bringing a passenger. So we have three different categories sharing at least the same starting and landing hub at the moment when they take off. And so we need to coordinate all. So the U-space model has some problems, and UTM, as we heard, is not. So we have to find a solution that ATC and ATM is applicable in an automated manner with the rule set of collision avoidance, ABS radar, sensors, with predefined routes, with like tunnels in the sky where different vehicles can then operate, and with a system that foresees any disturbances and problems. For instance, if one vehicle is running out of energy, if an emergency helicopter is crossing, if an obstacle is appearing, they should not be there, etc. All right.
Well, Yvonne, thank you so much for the enlightenment and the interesting updates on FlyNOW Aviation. By the way, if you see Gary Vermaak's name here on the moderator, I am not Gary. I'm Keith Sarich from the AAMI. I'm moderating today's event. And one thing that I'll say, though, we had a little bit of difficulty, Yvonne, in hearing you on the mic, and that could be technical. I'm not too sure if you're a little bit away from it or not. I know that thing could happen. Looks like your subtitles and your graphics were well. So what I'll do is from here on out, if anyone is having a little bit of difficulty hearing the speaker, I might just break in and just maybe recommend, if they can do that. But we were able to, of course, get the gist of what your presentation was, and it's exciting to see what's going on with FlyNOW Aviation. Appreciate you taking the time to present today, and I'm sure we'll see more great things with FlyNOW in the near future. So with that, I really appreciate your time for coming aboard and speaking today.
Thank you.
All right.